Ladies and gentlemen, welcome to my tutorial video channel. This video is on advanced problems on demand function, and here I will show how we can prove the properties of demand function mathematically. Please look at the right hand top corner of the whiteboard. Here two properties of demand functions are given. Number one, the demand function is a single valued function in income and price, and number two is the demand function is a homogeneous of degree 0. Now what is meant by single valued function in income and price? This means for a given level of income and prices of the commodities, there will be only one value of quantity purchased by the consumer. And second property is the demand function is homogeneous of degree 0. This means if the income of the consumer and prices of the commodities change in either direction, that is, they either increase or they decrease in the same proportion, then there will not be any change in the quantity purchased by the consumer. This means if the income of the consumer and prices of the commodities increase by same proportion, then the consumer will buy the same commodity bundle as he or she was buying before the change. Similarly, if the income of the consumer and the prices of the commodities decrease in the same proportion, then also the consumer will purchase the same bundle of commodities as he or she was purchasing before the decrease. Now I shall prove mathematically these two properties. Please watch carefully. Number one, single valued function in income and price. We start with the utility function of the consumer, which we assume U equals to x1 x2. U equals to x1 x2. This is the utility function, and the budget constraint is m equals to p1 x1 plus p2 x2, where m is the income of the consumer and p1 and p2 are prices of x1 and x2 respectively. From this utility function, we get del u del x1 equals to ddx of x1 x2 is equal to x2. This is what? This is mu x1. That is, we have differentiated utility with respect to x1, that is x2, and that is the marginal utility of x1. Similarly, del u by del x2 equals to ddx2 of x1 x2 is equal to x1, which is marginal utility of x2. Del u del x2 equals to ddx2 of x1 x2 equals to x1, which is the marginal utility of x2. Now at equilibrium, we know the ratio of the marginal utilities will be equal to the ratio of prices of the commodities. Therefore, at equilibrium, mu x1 by mu x2 is equal to p1 by p2. Therefore, x2 by x1 equals to p1 by p2. This means x1 p1 equals to x2 p2. This means x1 equals to x2 p2 by p1 and x2 equals to x1 p1 divided by p2. So here, this is the original condition of consumer's equilibrium, that is where the consumer is maximizing his satisfaction. So x2 by x1 is equal to p1 over p2. Therefore x1 equals to x2 p2 by p1 and x2 equals to x1 p1 by p2. Now look at this budget constraint. M equals to p1 x1 plus p2 x2. So M equals to p1 x1 plus p2 x2. This means M minus p1 x1 minus p2 x2 equals to 0. Now we shall put the values of x1 and x2 from here in this budget constraint. So putting the value of x2 we get M minus p1 x1 minus p2 into, now here we are putting the value of x2 which is x1 p1 by p2, that is p1 x1 by p2, p1 x1 by p2, p2 in numerator and denominator, so it goes away. So what remains? M minus p1 x1 minus p1 x1, so minus 2 p1 x1 equals to 0. This means two p1 x1 equals to M, that is x1 equals to M by 2 p1. Similarly, putting the value of x1, here we have put the value of x2 in the budget constraint and here we are putting the value of x1 in the budget constraint. So putting the value of x1, what do we get? We get M minus p1 into what is x1? x2 p2 by p1, x2 p2 by p1 minus p2 x2 equals to 0. This means M minus p1 in numerator and denominator, so it goes away. M minus x2 p2 minus p2 x2, that is M minus 2 p2 x2 equals to 0. This means 2 p2 x2 equals to M x2 equals to M by 2 p2. So we have got the quantities of x2 and x1, right? So quantity of x1 is M by 2p1 and quantity of x2 is M by 2p2. So hence it is proved that it is a single valued function. Hence it is a single valued function. This means for a given money income and for given prices of two commodities, the consumer will consume a particular quantity of the commodities and he or she will not purchase 1 unit less or 1 unit more. That is, there will be a single value of the quantity. This is called single valued function in price and income. So property number 1 is proved. Now let's get into property number 2, that is demand function is homogeneous of degree 0. Homogeneous of degree 0. As I have just said, homogeneous of degree 0 means if the income of the consumer and prices of the commodities change in the same direction and in same proportion, then there will not be any change in the purchase of the commodities by the consumer. Now, graphically, we have seen that if this is the budget line, say BL, and if the consumer is consuming say X1 and X2, now if the budget line shifts rightward, that means if the income of the consumer increases by a certain proportion or certain multiplier, it shifts parallelly rightward. So consumer intends to move to a higher budget line, say B1, L1, but at the same time, if the prices of the commodities also increase by the multiplier as the budget line, as the income of the consumer is increased, then this budget line will again shift parallelly leftward and the consumer will come back to the original budget line. So increase in income and increase in prices by same proportion will leave the consumer at the same point of equilibrium. Now we know this. Here I shall prove it mathematically. That is, when income of the consumer and prices of the commodities increase or decrease by same proportion, then the consumer will purchase the same bundle of commodities as he or she was doing earlier. We start with this utility function and this budget constraint. We know E equals to x1, x2. Therefore, del U del x1 equals to x2 and del U del x2 equals to x1, right? This is marginal utility of x1 and this is marginal utility of x2. Therefore, x2 by x1 equals to p1 by p2. This is the original condition of equilibrium. Original condition of equilibrium, that is where the consumer is maximizing his satisfaction by purchasing the commodities. Now suppose the income of the consumer and the prices of the commodities increase by alpha times. So what was the initial budget constraint? M minus P1 x1 minus P2 x2 equals to 0, which we have found out from M equals to P1 x1 plus P2 x2. Now M, P1 and P2 are being multiplied by alpha. So what will be the new budget line? The new budget constraint will be alpha M equals to alpha P1 x1 plus alpha P2 x2. So if M, P1 and P2 increase by alpha times, the new budget line or budget constraint, the budget constraint becomes what? Becomes alpha M equals to alpha p1 x1 plus alpha p2 x2. This means alpha m minus alpha p1 x1 minus alpha p2 x2 equals to 0. Correct? Now, what the Lagrange function will become? The Lagrange function will be, now those who are not familiar with Lagrange function may let me know about it so that I can explain you what is Lagrange multiplier and Lagrange function. And those who are familiar with Lagrange function, Lagrange multiplier will find it easy to understand. And even those who are not familiar with Lagrange function and Lagrange multiplier, still they will be able to understand this as I am explaining in a very simple and lucid way. So the Lagrange function will be L equals to x1 x2 plus alpha m minus alpha p1 x1 minus alpha p2 x2. L equals to x1 x2 plus alpha m minus alpha p1 x1 minus alpha p2 x2. This will be multiplied by what? By lambda. This will be multiplied by lambda, as lambda is the Lagrange multiplier. So the Lagrange function becomes L equals to x1 x2 plus lambda multiplied by, within bracket, alpha m minus alpha p1 x1 minus alpha p2 x2. Lambda is Lagrange multiplier. Okay, so this is the Lagrange function. Now we differentiate L with respect to x1. So del L by del x1 equals to x2 minus lambda alpha p1 minus lambda alpha p1 del L by del L del x1 equals to, here remains x2 and here we have alpha p1 x1 and lambda, so lambda alpha p1, and del L del x2 equals to x1 minus lambda alpha p2, right? So here we have differentiated L with respect to x1, that is, we have taken partial derivative of L with respect to x1, and we have got del L del x1 equals to x2 minus lambda alpha p1, and here we have taken partial derivative of L with respect to x2, and we have got del L del x2 equals to x1 minus lambda alpha p2, right? Now this is equal to 0 and this is equal to 0. Therefore, x2 minus lambda alpha p1, x2 equals to lambda alpha p1 and x1 equals to lambda alpha p2. Del L del x1 equals to x2 minus lambda alpha p1 equals to 0. Therefore, x2 equals to lambda alpha p1. Similarly, del L del x2 equals to x1 minus lambda alpha p2 equals to 0. Therefore, x1 equals to lambda alpha p2. Therefore, x2 by x1 is equal to lambda alpha P1 divided by lambda alpha P2. We cross out lambda and alpha. So what remains? x2 by x1 equals to P1 by P2. You see, this is the original condition. This is the original condition. x2 by x1 equals to P1 by P2, which we had with earlier budget constraint, that is with earlier income of the consumer and prices of the commodities, and the same equilibrium condition is derived here. Now we shall take partial derivative of L with respect to lambda. So partial derivative of L with respect to lambda. What we get? We get del L del lambda, del L del lambda equals to alpha m minus alpha P1 x1 minus alpha P2 x2 equals to 0. This means alpha m minus alpha P1 x1 minus alpha P2 x2 equals to 0. Right? Now you see, before the increase in income of the consumer and prices of the commodities, this was the budget constraint or budget equation, and after increase of prices and income of the consumer, this is the new budget constraint or new budget equation. And we have seen that the same original equilibrium condition is derived by taking this set, which set the new set of income and prices, that is alpha m, alpha P1 and alpha P2. So it is clearly seen that the demand function with the set of m, P1 and P2 is derived from the same equation as the set of alpha m, alpha P1 and alpha P2, isn't it? So the demand function with m, P1 and P2 is derived from the same equation as alpha m, alpha P1 and alpha P2. This means there is no change in quantity purchased by the consumer as a result of change in, here in this case, increase in income of the consumer and prices of the commodities by alpha times. So the function is homogeneous of degree 0. Homogeneous of degree 0. Right? So, ladies and gentlemen, we have proved these two properties. That is, property number 1 is the demand function is single valued function in price and income, and property number 2 is the demand function is homogeneous of degree 0. The first property means that for a given income of the consumer and for a given set of prices of two commodities, there will be only one value of the quantity purchased by the consumer. And second property means if the income of the consumer and prices of the commodities change in either direction, that is, they either increase or decrease in same proportion, then there will not be any change in quantity purchased by the consumer. That is, the consumer will buy the same bundle of commodities as he or she was doing before the change. And we have proved mathematically these two properties. This is the utility function, this is the budget constraint, this is the marginal utility of x1, this is marginal utility of x2, that is del u del x1 is marginal utility of x1, which is x2, del u del x2 is marginal utility of x2, which is x1. At equilibrium, mu x1 by mu x2 equals to p1 by p2. This means x2 by x1 equals to p1 by p2. This is the original condition of equilibrium of the consumer. This means at this point the consumer is maximizing his satisfaction by purchasing the commodities. From here we have found out the values of x1 and x2. x1 equals to x2 p2 by p1 and x2 equals to x1 p1 by p2. Now this is the budget constraint, m equals to p1 x1 plus p2 x2. We have simply put the values of x1 and x2 one by one in the budget constraint, right? And we have found out x1 equals to m by 2p1 and x2 equals to m by 2p2. This means there is a single value of quantity purchased by the consumer of the two commodities x1 and x2. So property number 1 is proved. Now in case of property number 2, that is, we have to prove that the demand function is homogeneous of degree 0, that is, when the income of the consumer and prices of the commodities change in the same direction and in the same proportion, then there will not be any change in consumption of the commodities by the consumer. That is, the quantity consumed will remain same. We have done the same, we have taken the same utility function and budget constraint, and here it is del u del x1, which is x2, del u del x2, which is x1. Therefore x2 by x1 by p1 by p2, this is the original condition of equilibrium. That is, here the consumer is deriving maximum satisfaction. Now suppose m, p1 and p2 increase by alpha times. So the new budget constraint becomes alpha m, that is m multiplied by alpha, income is multiplied by alpha, equals to alpha p1 x1, price is multiplied by alpha, plus alpha p2 x2, p2 is multiplied by alpha, so we get alpha m minus alpha p1 x1 minus alpha p2 x2 equals to 0. Now we have taken Lagrange function, and the Lagrange function will become what? It will become L equals to x1 x2 plus lambda, that is the Lagrange multiplier, lambda into within bracket alpha m minus alpha p1 x1 minus alpha p2 x2. So here we have differentiated L with respect to x1. So we have found out del L by del x, del L del x1 equals to x2 minus lambda alpha p1, and del L del x2, that is differentiating L with respect to x2, we have found out del L del x2 equals to x1 minus lambda alpha p2 equals to 0, and this is also equals to 0. x2 minus lambda alpha p1 is 0. Therefore x2 equals to lambda alpha p1 from here, and x1 equals to lambda alpha p2 from here. Therefore x2 by x1 equals to lambda alpha p1 by lambda alpha p2, lambda alpha in numerator and denominator, so it goes away. So what remains? x2 by x1 equals to p1 by p2, which is the original condition of equilibrium, right? Now we are taking partial derivative of L with respect to lambda. What do you get? Del L del lambda equals to del lambda equals to alpha m minus alpha p1 x1 minus alpha p2 x2, which is equal to 0. That is alpha m minus alpha p1 x1 minus alpha p2 x2 equals to 0. Hence, it was the original budget constraint, and this is the new budget constraint. And we have already seen that we have derived the new equilibrium condition. That is, we have reached at the equilibrium condition of the consumer with the changed prices and changed money income of the consumer. So it proves that the demand function with the set of prices and income M, P1 and P2 is derived from the same equation as the set of income and prices, which are alpha M, alpha P1 and alpha P2. This means there is absolutely no change in quantity purchased by the consumer. That is, the demand function is homogeneous of degree 0, right? So I hope it is well understood by you. Still, if you have any doubt in your mind, if you have any query, please feel comfortable to let me know through the comment section. I shall be more than glad to respond to all the relevant queries and doubts, right? And if you think the video has benefited you, please do share the video with your friends so that they can also get benefit by watching this video. Okay, and finally, thank you very much for watching this video. Please do like and subscribe my channel. Okay, stay well, goodbye.